Here's an interesting problem I got in my quantitative portfolio management class. I thought it was extremely interesting and worth a share. The question goes, suppose you were constructing a portfolio of two stocks X and Y. Stock X has a normal distribution with a mean of 0.1 and a variance of 0.1, and stock Y has a normal distribution with a mean and variance of 0.2, and both of these stocks have a correlation of 0.4. How do you calculate the expected return and expected volatility of the portfolio when you have an equal distribution between both stock X and stock Y? The first important thing to note is that when we're using this notation for the normal distribution, the first number represents the mean and the second number represents the variance. A lot of people get it mixed up and believe that the second number means standard deviation. No, it actually means variance, which is the square of the standard deviation. Okay, with that in mind, we can calculate the expected return of a portfolio of 50/50 stock X and stock Y. To calculate the expected return, you just multiply the weight times the mean of the stock. So in this case, it would be the mean of X plus weight of X times plus the weight of Y times the mean of Y, which in this case, 0.5 for both of them, times 0.1 plus 0.5 times 0.2, which equals 0.15. The expected return of this portfolio is 0.15. Calculating the variance for the portfolios is a little bit more challenging, but we do have a general formula that has already been derived. Essentially, you're multiplying the weight of X squared times the variance of X plus the weight of Y squared times the variance of Y plus 2 times the correlation times the standard deviation of X times the standard deviation of Y. We won't go into the derivation of this formula, but this is a formula used to calculate the variance of any portfolio. Anyways, we can plug in the numbers and we get 0.5 squared times 0.1 plus 0.5 squared times 0.2 plus 2 times the correlation is 0.4 times the square root of 0.1 times 0.2. This evaluates to roughly 0.10328, and that is the variance of this portfolio. Okay, so for the second part of the question, we are trying to find the expected return of the minimum variance portfolio. So this is a minimization problem which requires the use of derivatives. To make it easier to calculate, we can represent the weight of y as 1 minus the weight of x. The reason being is that this portfolio is only made up of two assets, and both of them combined must equal 1. So by doing so, we can represent the entire equation using only one weight variable, which would allow us to differentiate it. We can plug this back into the initial variance equation and get a formula only involving the weight of x. So we would have the weight of x times x plus 1 minus the weight of x times y, the uh, normal variable y. And this would give us the equation y, weight times the variance of x plus 1 minus the weight of x times the variance of y plus 2 times the weight of x and 1 minus the weight of x plus the correlation of both variables and the standard deviation of x and y. Given this formula, we can now differentiate it with respect to the weight of x and set it equal to 0. First, we get the partial derivative of the variance formula with respect to x, and that's going to give us 2 times the weight of x times the variance of x minus 2 times 1 minus the weight of x times the variance of y plus 4 times the quantity 1 minus 2w and followed by the correlation and standard deviation of both x and y. Notice that all of these numbers have a coefficient with a factor of 2, so we can actually divide everything by 2. This will give us the formula, the final formula of the weight of x times the variance of x minus the weight of y, which is 1 minus x times the variance of y, plus 1 minus 2w. This is actually supposed to be 2 over here. times the correlation and the standard deviation of both. Now let's plug in the known variables. So all the unknowns are just the weight of x, but we do know the variance of x, which is 0.1 minus 1 minus the weight of x, and the variance of y is 0.2 plus 1 minus 2, the weight of x. The correlation is 0.4, and the standard deviation of both is 0.1 times 0.2. And this actually turns out to become a linear equation, which we can just quickly solve for x. When you put this into a graphing calculator, you get that the weight of x is equal to 0.768, and that means that the weight of y would be the inverse, which is one of the weight of x, which is 0.2343. This means that the weight of x is 76.757 of the portfolio, percent of the portfolio, and the weight of y is 23.43% of the portfolio. Now we can calculate the expected return. So the expected return given the weight of x times x plus the weight of y times y is just going to be 0.7657 times 0.1 plus 0.2343 times 0.2, and that's going to be 0.12343, and that's the final answer. I hope you find this problem interesting as I did, and let me know if you want me to solve any other quant problems.